Have you ever wondered if there's a problem out there that's so tough it could actually break an AI? Well, today we're going to dive into a project that's trying to do just that. It's all about finding the absolute limits of artificial intelligence by building the ultimate intellectual obstacle course for a digital mind.
So how do you even do that, right? When you've got an AI that seems to know, well, everything, how do you pinpoint where its logic starts to fall apart? How do you push it beyond its training data and make it truly reason its way through something new?
And the answer? Well, it sounds simple. You don't try to trick it with a riddle. Nope. You design a problem that is so fundamentally hard, you force that AI right to the very edge of what it's capable of, and then you give it a little nudge.
And really, that's the whole mission right there. This is not about cheering for the AI when it gets something right. It's about designing the ultimate stress test for a digital brain. Because, the biggest breakthroughs happen when you figure out exactly how and why something fails.
Okay, so the official goal is to create these things called computationally intensive prompts. Just think of them as problems that need a mind-boggling amount of calculation and pure logical horsepower to solve, way, way beyond a quick Google search. They're built for one single purpose, to really push the most advanced AIs we've got to their breaking point.
So what do these tests actually look like? Well, we're not talking about philosophical questions here. The method is all about pure code and computation. Every single challenge is a high-stakes calculation that has one and only one correct, verifiable answer. There's just no room for guessing or being kinda right.
And here's the real kicker. The AI can't just type out the answer in plain English. Oh no. It has to write working Python code that actually generates the solution. That's a massive leap in difficulty. It's kind of like the difference between describing how to build a car and actually getting your hands dirty and building the engine yourself.
Now, the AI isn't starting completely from scratch. It's given a specific toolbox, a set of essential Python libraries it's expected to use. And we're talking about the heavy hitters here, like NumPy and SciPy. These are the powerhouses for scientific computing used for all sorts of heavy-duty math. So the AI doesn't just need to know the ideas, it has to be completely fluent in the actual language that scientists use to solve these problems.
All right, so the AI writes some code, but how do you know if it's right? That's where this critical idea of ground truth comes into play. Every single problem has a specific known answer calculated out to an incredibly high degree of precision. It is the absolute gold standard. The AI's code either spits out this exact number or it fails. It's totally black and white.
But these incredibly complex problems don't just write themselves. That is where a human expert has to step in. So let's take a look at the role of this subject matter expert. Basically, the mastermind who's designing these insane intellectual obstacle courses. And it's not just random, it's a very structured process. The expert first picks a broad field like physics or math, and then drills down into a specific little corner of it. Then they create the prompt, they figure out that super precise ground truth answer we talked about, and, this part's super important, they make sure the problems are different enough so the AI can't just learn a pattern and cheat the system. But let me be really clear. We are not talking about your standard textbook problems. Not even close. These are a whole different animal. For a prompt to even make the cut, it has to meet a really strict list of criteria. And this list is no joke. I mean, look at model breaking difficulty. That's the whole point, right? The problem is literally designed to find the AI's blind spots. And self-contained is just as crucial. It means the prompt gives the AI every single piece of information it needs. No tricks, no hidden clues. So there are absolutely no excuses for getting it wrong.
So where are all these intellectual showdowns actually happening? Well, the project covers a bunch of different scientific fields, but one of the main arenas, one of the key battlegrounds, is mathematics. It's really the purest test of logic, abstract thought, and raw computational power. And just look at the sheer breadth of knowledge needed here. This is so far beyond high school algebra. The AI has to be a master of everything from differential equations all the way to chaos theory. We're talking about analyzing things called strange attractors. It basically needs to be a genius-level expert in all of these fields all at once.
Okay, I know this has all been a little bit abstract, so let's make it real. Let's actually look at an example of what one of these challenges, even a so-called easy one, really looks like in practice. So the first part of the problem is to use a very specific, super efficient algorithm to calculate the value of pi out to 1,000 decimal places. I mean, just doing that correctly requires a really deep knowledge of numerical methods. It's a huge challenge on its own. But it doesn't just stop there. Of course not. The full prompt then requires the AI to independently double-check its own work using a totally different formula. And for the final step, it has to report the time difference between the two calculations. So, you see, this isn't just about getting the right answer. It's about proving it, about verification, and about analyzing its own performance.
You know, seeing how these incredible challenges are actually put together really gets you thinking. So I'm going to leave you with a question. If you had the chance to design just one problem, a single, elegant, but brutally difficult challenge, what would you come up with to try and stump the world's smartest AI?